The first 10 minutes you walk, you are barely burning fat. And if you stop there, your body has not yet shifted metabolic states. It sounds contradictory to every piece of advice that says walk to burn fat, but this is physiology. When you begin to move, your body is not thinking about fat loss. It is thinking about stability. Heart rate gradually rises. Breathing deepens. Blood is redistributed toward working muscles. The sympathetic nervous system increases slightly, enough to activate the system, but not enough to trigger a stress response. During these early minutes, the primary fuel is glucose in the bloodstream and glycogen stored in muscle. This is an intelligent strategy. Glucose produces energy quickly with fewer conversion steps, making it ideal while the body is still assessing the situation. Exercise physiology textbooks such as Exercise Physiology, Nutrition, Energy, and Human Performance clearly describe this phenomenon. The initial stage of movement prioritizes carbohydrate before gradually transitioning to fat oxidation once the cardiovascular system reaches a steady state. Many people misunderstand this point. They think, if the first 10 minutes are not burning much fat, then walking is ineffective. But this glucose phase is precisely the foundation that allows sustainable fat burning to occur later. As muscles contract rhythmically, an important mechanism begins to activate. GLUT4 transporters move to the surface of muscle cells. This allows muscles to absorb glucose without requiring high insulin levels. As a result, insulin in the bloodstream gradually declines in a natural way. No extreme dieting, no forcing the body, just controlled movement. Why does this matter? Because high insulin is a store fat signal. When insulin stabilizes at a lower level, the internal environment begins to change. But the body does not jump directly from rest to optimal fat burning. It needs time to determine that this movement is not a short-term emergency. Think of your body as an extremely cautious energy management system. If you walk for a few minutes and stop, the body will not unlock long-term reserves. It has no reason to. But if you continue, heart rate steady, breathing controlled, the system begins to recognize. This is sustained movement. A longer-term energy strategy is required. That is when the foundation for fat oxidation is laid. Most failures in fat loss do not come from lack of effort. They come from stopping too early, before the system has time to shift biologically. The first 10 minutes are not wasted. They are the necessary preparatory phase that unlocks what comes next. In the next section, we will move into the true turning point. When insulin drops sufficiently, signals from muscle reach fat tissue, and lipolysis begins quietly inside the fat cell. After about 15 minutes, the body begins to recognize that this is not a brief movement. This is when biology shifts gears. As muscles contract continuously at a moderate intensity, glucose enters muscle cells through a contraction-dependent mechanism, without requiring high levels of insulin. As a result, insulin in the bloodstream declines to a lower and more stable level. This is the decisive point. Insulin is the lock on the fat cell. When insulin is high, the fat cell receives the message. Energy is abundant. Store it. When insulin decreases, the message changes. Fast energy is being used. Long-term reserves may be needed. At the same time, muscle is not only consuming energy, it is signaling. Molecules known as myokines are released into the bloodstream. These are not hormones in the traditional sense, but biological messages sent to the liver, fat tissue, and even the brain. The body is moving steadily, prepared to supply fuel. Fat cells are not passive. They respond to the surrounding endocrine environment. When insulin is low and catecholamines rise slightly, the enzyme hormone-sensitive lipase is activated. This enzyme is responsible for breaking triglycerides into 3 free fatty acids and 1 molecule of glycerol. This is the moment lipolysis begins. Not dramatic, not sudden, but decisive. From this point, energy is no longer locked inside the fat cell. Fatty acids leave the cell, enter the bloodstream, and move toward working muscles. If you stop before this process stabilizes, you have only used glucose. But if you continue, you are entering the phase where the body officially shifts to a fat-burning strategy. The key is not training harder. It is sustaining movement long enough for insulin to drop, for muscle signals to circulate, and for the enzyme inside the fat cell to be activated. Fat loss does not begin with sweat. It begins with the right endocrine signal at the right time. After about 20 to 30 minutes, the body is no longer experimenting. It has chosen its energy strategy. At this point, the cardiovascular system reaches a steady state of oxygen consumption. Heart rate no longer continues to rise. Breathing becomes deep and rhythmic. Oxygen is delivered sufficiently and continuously to the working muscles. This is a required condition for effective fat burning, because fatty acid oxidation depends entirely on oxygen. When fatty acids leave the fat cell, they travel through the bloodstream and enter the mitochondria inside muscle cells. Mitochondria are not merely energy factories. They are the control centers that determine whether you truly burn fat or simply release it and then store it again. Inside the mitochondria, beta oxidation takes place. Fatty acids are broken down step by step, producing acetyl coenzyme A, which then enters the Krebs cycle to generate adenosine triphosphate. This is the actual energy used to sustain movement. Unlike glucose, fat produces more adenosine triphosphate per molecule. That is why, once the system has shifted into stable fat burning, you experience steadier energy, fewer fluctuations, and fewer sudden drops in performance. Why is the 30-minute mark so often mentioned in research? Not because it is a magical number, but because by this time, insulin has stabilized at a lower level, catecholamines have increased slightly without creating stress, oxygen delivery has reached steady state, fat-breaking enzymes are functioning smoothly, and fatty acids are continuously transported into the mitochondria. All systems are synchronized. A fascinating scientific detail is that when fat is oxidized, the carbon in the fatty acid molecule combines with oxygen to form carbon dioxide. Most of the mass of burned fat leaves the body through breathing, not through sweat. Research published in the British Medical Journal calculated that the majority of oxidized fat mass is exhaled as carbon dioxide. That means each deep, steady breath during walking is removing a small amount of carbon from your body. There is no dramatic moment when fat melts away. There are only thousands of chemical reactions occurring quietly inside mitochondria. 30 minutes is not about burning a few dozen extra calories. It is the moment the body shifts from short-term energy expenditure to metabolic recalibration. When this state is repeated daily, the body begins to adapt by increasing mitochondrial density, improving its ability to use fat, and becoming more flexible in fuel selection. That is, when walking is no longer a gentle activity, it becomes a biological signal strong enough to change how your body manages energy. When you repeat that cycle day after day, what changes is no longer just the amount of fat burned in each walking session. What changes is the way fat cells themselves behave. Most people think fat loss means shrinking fat cells. That is true, but it is only the surface. At a deeper level, consistent movement begins to regulate gene expression inside fat tissue. In a prolonged sedentary state, many genes inside fat cells are expressed in a storage direction. Increased triglyceride synthesis, increased low-grade inflammatory signaling, and reduced sensitivity to fat-releasing signals. Fat cells become defensive. They hold on to energy because the surrounding environment does not signal that energy is being used steadily. When you walk for 30 minutes each day, the biological environment shifts. Insulin becomes more stable. Baseline inflammation gradually decreases. Signals from muscle through myokines are repeated consistently. Research on gene expression in adipose tissue shows that moderate but regular exercise can reduce activation of genes related to inflammation, increase activation of genes involved in fatty acid transport and oxidation, and improve insulin sensitivity within fat tissue. The fat cell is not defeated. It is retrained. At the same time, mitochondria inside muscle increase in both number and quality through the process of mitochondrial biogenesis. More mitochondria mean a greater capacity to use fat even at lower intensities. The body becomes more flexible in its choice of fuel, a phenomenon known as metabolic flexibility. You are no longer heavily dependent on sugar to maintain energy. The effects extend to the brain as well. After 30 minutes of rhythmic movement, serotonin and dopamine increase slightly but steadily. Brain-derived neurotrophic factor is stimulated. This improves focus, mood, and regulation of eating behavior. As the nervous system becomes less stressed, hunger hormones such as ghrelin stabilize and leptin sensitivity improves. Hunger begins to feel physiological rather than emotional. This is a crucial point. When inflammation decreases and hormones rebalance, the body is less inclined to store fat defensively. Visceral fat is no longer protected in the same way it is under chronic stress conditions. There is no dramatic transformation in a single day, but each walking session is a repeated signal. Biology learns through repetition, cells adapt, the endocrine system recalibrates. The brain changes how it responds to energy. Eventually, fat loss is no longer a forced action. It becomes the default state of a system that has been rebalanced. Walking 30 minutes each day is not a gentle solution. It is a process of resetting how your body manages energy, from genes and hormones to mitochondria and the nervous system. When the entire system changes, the external result becomes inevitable.